Hey, what's going on, folks? It's Mike here, and welcome back to my Modern C++ series. In today's lesson, we're going to continue talking about stream-based I/O, this time looking at how to read files. So with that said, let's go ahead and take a look at some stream-based I/O from CPP reference here. We'll use this as our guide here, taking a look at input, output library here, and stream-based I/O. Now, previously, we've looked at the standard cin function here, so let's go ahead and just take a brief recap at that. And let's see, where do we have that? Well, we were looking at the basic global object that was defined in ifstream here for input stream. And again, we just had cin and the wide character version of that as well. And we're going to notice when we're working with files, we have a lot of the similar functions available, the member functions, but we want to work with files here. So if you didn't see the previous video that I did, we went ahead and scrolled down and we looked at output last time. So make sure you're subscribed and check that out here. But today we're going to be looking at input files. Now, again, I'll remind you that we're going to actually be looking at fstream here as far as the header that we include, which includes both output and input. In the same way that iostream header that we've been including for, well, pretty much this whole series, and well, other than when we looked at standard print, and at that, it sort of contains both the input and the output. So again, that's why you're going to see fstream, which again, I'll keep open here, but let's go ahead and dive into input file streams, which is basically saying input or reading in data. So we're reading files with this header here. So I'll go ahead and just scroll down here just so we can see here. I mean, the main thing that we're going to want to do is take a look at the constructor here. And basically, we want to be able to have the file name here that will pass in. And then we can also pass in different types of modes here. Now, different types of modes that we have that might be interesting, for instance, for the data that we're reading in, like if it's a binary file, for instance. I mean, these are the types of things that we're going to use here. If we're constructing things as an input file stream, we've sort of got that abstraction, I guess, built in, meaning that it's defaulting. We don't need to set the mode here to just being read only here. Okay, and it could create just a generic file and make it for read and write, for instance, by setting the iOS base for in, and if you see the other mode here for out, that ultimately gives you the most flexibility. Now, I'll just go ahead and remind you briefly. I talked about this in the other video a little bit more here. But the main thing is, if I have some file here, let's just call it my file .txt. I mean, really how that is represented somewhere in the underlying data here, at least with the stream-based IPO, is we have a stream here, and it's actually labeled here, basic file buff here. So I'll just draw this as file buff here. Right, it's just an array that's showing off the different positions here. So we could read to it, we could write to it. iStream is just specifically going to be for reading in data here, okay? But that's what we're navigating here, this little array here when we use for the different commands, or when we're reading and getting a new line, basically looking for the next end line character, where we'd be grabbing like a chunk of this at a time here, okay, based off the different read functions that we use here. So anyways, let's go ahead and just kind of look at some of these basic examples here. I think we'll do binary in another video here, but let's just go ahead and keep that open just so we know what we're working with. But let's go ahead and do a standard input file stream here, F. And we are going to need to create some sort of file here that we want to read from. So let's just practice very briefly what we did last time. So let's do an output file here, my file.txt. And that's going to go to default to being an output file. So let's just go ahead and write some data into it. Hi, my name is Mike. Let's do output here. Some more text, something like that here. And again, as I mentioned, we don't really need to close these. These are using RAII. So the destructor will be called and it should close the file here. I think that's documented here. Just as it destructs the, it destructs the iStream, so whatever that internal buffer is, and closes the file here. Okay, we talked about why you may or may not want to do that. I mean, sometimes you could close early if you want and check if there's like an error closing, but that's, again, something that you could do here. So let's go ahead and just start that, just to recap, with creating a file that we'll read from. Okay, just as an example. Let's go ahead and compile this. Okay, so if I run my program, oops, yeah, double ran it, there we go. We do have now, let's go ahead and write this out here. file here with hello, my name is Mike, some more text here. Oh, yep, and we should probably have a end line here. There we go. That's a little bit better here. Now we can see 2 lines in our file here. Okay, so now let's go ahead and read from that file here. And again, we want to say my file.txt. That's the one that we're going to open for reading here. And usually what I want to do here is check if the file was opened, for instance. And there's all sorts of reasons why it might not be open. Maybe the file doesn't exist, for instance, which very briefly, let me bring in from another window here. You can use the file system API, which we haven't talked about. It might deserve its own video here. There is an exists member function. So you could include file system if you're on C++ 17 and do standard file system, standard : file system exists like this. Let's actually just do it just to make our lives easier here. Just to verify that it exists here. So we'd say like, and standard file system exists my file.txt. Okay, and we'll need to include that header here. So we're jumping a little bit ahead since we haven't talked about file system, but that's okay. You know, we can do things a little bit more flexibly here. Okay, else, you know, let's just print out. Let's practice our good error messages. File does not exist here. Okay, and that's of course using the standard error stream, which is open with every process. That is effectively a file as an abstraction, but it's writing to that buffer. And let's do a little end line here. Actually, I'm just going to write the /n here, just so it writes out everything. Okay, so let's go ahead and run this. And I didn't get any error message or anything, so it looks like our file exists. Let's go ahead and read from it. So how do I read from this file here? Well, I'm going to show you a couple different ways here to read the data. And probably the simplest paradigm is to, well, I need to sort of like read or parse this line by line. So there's a couple different things that you could do here. So again, you know, maybe you'd write like, I'm going to use a string here for now, at least to show you first how to like, just basically, I need somewhere to basically read a line and store it here. So let's see what we've got here as far as our member functions. Well, we've got some handy things like get to extract characters. That's plural here. Let's see here, because I could do the characters and the count here. But if I don't really know, what I probably want to do is just use getLine here, which extracts characters until a given character is found. Now, what is that character? Let's go ahead and just check the documentation here. Let's see, I could use getLine and then pass in a count, or I think there's an overload where I could just put, let's see here. Can I just use the getLine as the free function? Yeah, I could use getLine and then actually pass in a few things here. Let's use this one here. What's this function template here? I think this is what we actually want here, where we just pass in the input, and then we could pass in optional character delimiter here. Yeah, this will be a little bit easier here because the delimiter will basically be an end-line character. So let's just go ahead and do this here, getLine. Now our file that we're passing in isn't the standard input here, cin, for character input, but it's going to be our file for reading here. Okay, so let's go ahead and hold on to that. And let's just go ahead and do one of these for now. Use standard getLine. Where are we reading to? File f. Again, that's our input file here. Input file. Let's name this just a little bit better here. Input file. And let's do input file. And we'll store it in the line. And let's go ahead and write something like red, colon, line. Now, if this line contains an end-line character, we don't need to put another end-line character here, but I'm just going to do it anyways, just so you see it run. But let's go ahead and do that. Oh, what did I do? Did I mistype something? Input F file. There we go. Delete. Let's go ahead and rerun. Oh, I guess I did that twice here. That's the glories of copy and paste. There we go. So it read, uh-oh, nothing. Well, this is a little bit of a subtle thing here. And I talked about it a few times about like, well, when do we need to close our file to check an error? I can't have two pointers, or rather I can. Let's say I can do this here. So this is my output file here. Here's my like input file. And you can think about these as files here, but this is the C++, has a struct or something, or a class maybe representing the internals. Both of these are going to point to the same sort of like file handle. They're the same thing, right? We're sharing it. We want to be able to maybe have the same file pointer that can do like read operations and write operations to the same buffer here. So what's happening here, why I didn't get a line here is, well, I'm pointing to the same thing here, okay? Which basically means I'm probably at the end, and I'm not able to read anything. So here's what I can do here. So I just have to pay attention a little bit here. Just going to out file, and I'm going to close it, right? We're done here. There's a couple different things we could also do. We could just put this, again, in its own scope. Let's go ahead and do that here. That would be the other operation here, right? Because we need this close to be called here. But this is an instance where you might want to call close just to be explicit and show that you're done. Both of these options will work here. Now if I run it, you'll see, hi, my name is Mike here. Okay, so a little bit of review from last time, writing out a file, but also just trying to understand what the underlying file abstractions are here, so that when we read our file here, which happens to be pointing to the same file in the operating system, we are getting a line here. So let's go ahead and just repeat this experiment here. Let's do this, twice, because we want to be able to read all of our lines here. Now I can make this a little bit bigger, and we could just play a little bit here with the code for reading files. Now we should see, hi, my name is Mike, and some more text, which is exactly what we've written out in our file here. Okay, so again, this is the portion that we care about for reading files here. So no problem there. Now, of course, you're not going to necessarily know how many lines you have here in your file. So usually what folks will do is they'll say while, and let's go ahead and just abstract this. And we're just going to go ahead and put this in a loop here. Okay, so no problem here. And every time we start our loop here, we're going to see if we're able to get a line here and read it in here and just write it here. Okay, so that'll do the exact same thing. And that's what, for those of you who are starting your C++ journey, that's 90% of, what you're going to need to do when you're starting out, just reading and writing some data here. Okay, so something like that here. Okay, so that's the first sort of experiment here. Now let's do a few other experiments here. And again, I'm going to put these in their own scope so that it closes the file here. Okay, and let's just be explicit about that here. Let's do another experiment here. Let's go ahead and write another file here and maybe read from it. So let's do another one, my file, how about 2 here, or something like that, to my file 2. And the other thing that you might end up doing, and I end up doing this a lot for cases where I have like geometry data. Again, for those of you following the C++ series with OpenGL, for instance, you might have like data that looks like this, something that looks like this. Let's go ahead and do this with a few different numbers here. 5, 6, just as long as the numbers are different, it doesn't really matter. And we can have them be double digits too, no problem. Something like this. But this is pretty like structured data here, right? You're reading in some like file format, right? You've got a bunch of, I don't know, units in a game that are positioned at these, 3D locations or something. And now we want to actually read from it. So let's go ahead and do our read again. And I'm just going to take the sort of small portion here. Let's just take a chunk of this here and do our next experiment here. And I'll put it in a scope here just because we want to be able to like open and close our files appropriately here. I'm going to not test for the existence of the file every time, but generally speaking, I would say that is a good thing to do, to check and see that the files that you're opening, especially for reading, actually exist, so you can send some message to your users here. And of course, this is going to be my file 2 here. But we do know something about the structure of this data here. So what I want to do instead here is basically go back to our old friend here when talking about input. And instead of reading in cin, right, like we would do and write our data, let's just go ahead and take x, y, and z here. And what I'll do is say for our input file, I would go ahead and read in these values for x, y, and z. And that should do the trick here. Because what this is going to do here is basically ignore the white space and then just write into X, Y, and Z. Okay, X, Y, and Z. Let's go ahead and put some commas in here. And let's see if we get our data back here. Okay, let's go ahead and do that. And there it is. There's the whole line for you. And you can format this a little bit neater than I have here. Let's do something like this is reasonable here, right? Use spacing as you will here. Let's go ahead and try this out here. I know I'll make at least one mistake here. Let's see. Oh, semicolons, of course. Pesky semicolons are always causing trouble. There we go. And now, for our second run here, we've got our second file that we write to, but we're able to read the formatted data. Now, the important part, or what I'm trying to introduce here, is one, if you have structured data, right, you can just read in the format. And then if you don't, read in the data, or you get an error here or something, right, you can sort of handle that because you do want like very structured data, right? It's not going to be uncommon that you have structured data. But this is also telling us again and reminding us that even though we have a file here, right, it's the same stream of abstractions. And we're going to look at another stream of abstractions. So make sure, again, you're subscribed for this, but or following along, on my courses.mshot.io. And we'll have string streams, which also work in the exact same way. And then you can sort of read in each little token that's separated by a white space, for instance, in this format here. So it's kind of nice here. And again, hopefully emphasizing how strings work here. All right. So anyways, the final example that I'll use here, and we'll just go ahead and let's just do another final example here. Let's just call this, this is example 3 here. This is part of example 2, using sort of structured data. And then this is example 1, basic loop to read all data. The other thing that you're also going to commonly do here is instead of reading all these lines here, right, let me go ahead and just supercharge this example here. You're probably also going to do something like, create a vector of standard string or something, right? And you're going to want to say this is like lines or something. And then you'll do, lines, pushback, line, something like that. Again, push back, or you could do like in place back so you don't make a copy here, right? Again, you can use all these different things that we've learned here. Again, now you have that file, basically the contents stored in your own memory version here, okay? Okay, so that was just a little adaptation of example 1 here. But with example number 3 here, let's just go ahead and do another ifstream here. Let's call it input file. Let's use my file .txt. And you might want to read, again, using some of the member functions here, just doing like a pure read here. And again, we have the same things where we can position here. And let's go ahead and do an example here. And you can kind of put this together with the previous lesson here. But again, this will show you all the ideas if you missed those. Let's go ahead and do read, and then let's do a seek G. So seek is seeking the position here. So let's go ahead and let's do input file here, seek G. And we might have to, let's just shrink this window just a little bit here, just so you can see seek G. We need to find our position here. So we could do like a literal, like go to the start of the file here, or you can do positions here with the offsets here. Okay, so if you remember what those were from last time, let me see if I remember from the overload here as well. Here's the offset. So what I'm going to do here is I want to go to the 5 characters from the ending here. Okay, let's see if we got that much right here. Okay, we haven't done anything yet. And then what I want to do here is I'm going to create a character buffer of 5 characters. And then let's go ahead and do our read here, which is going to do a read from input file here. Input file. Yep. Read. And we need, well, where are we going to store this stuff? Let's store them on this buffer here, which is stack allocated, right? Because you might not always want to use a string here. And how many characters do I want to read? 5. Okay. And then let's just do a cout here and say last 5 characters are. And let's go ahead and write out that buffer. it's a character buffer, we should be able to just write it out here. Again, we have the overloads. We could just do like .write again if we want, but let's go ahead and try that. And the last 5 characters are text, okay? Let's go ahead and see if that's true here. Let's open up my file here and kind of just show what we did here. So again, I opened this file up for reading. I seeked my position, so 5 characters back from the end. So I go to the very end here, and then I go back 1, 2, 3, 4. Well, actually 5 here. Let me see if I can highlight it here, because there's an end-line character here, okay? So that's why I have my 5 characters here. This last one here, right, it's invisible, but it is just that end-line character, /n, okay, which counts as 1 character, okay? So it's hidden in the file. You can't see it, but that's the idea here. And then I store those in a buffer here that's been allocated for 5 characters, and then I can write it out here. Okay, so you don't have to use string. Again, that's just showing you, right, if you don't want to use like standard library stuff, you can still allocate your own buffers, again, because the underlying data when you're reading and writing is just this guy here, this buffer here, okay? That's everything, you know, when it comes to like performance. Just think of things as linear arrays and how to navigate them, okay? Whether you're using the stream IO interface with string streams, which is coming up, so again, look out for that, files, which we've been talking about, or just general input-output with the global input-output objects like cout, cin, and so on. Alrighty, folks, so that's about it for reading. In writing, we might look at binary files, and then of course we're going to look at string streams at some point. But then you're going to be a stream expert if you've watched everything. So if you haven't already, go ahead and check out courses.msha.io. There I am. You can check out my C++ course if you're really ramping up from the start, or other courses. But this series is there, available for free in a distraction-free environment, so feel free to take advantage of that. And as always, folks, thanks for your time and attention. It's always fun to talk about this stuff with you folks, and let me know if there's other things with reading and writing that you've done. I know it's fun for competitive programmers sometimes to see how fast you can like read and write data and different optimizations or systems calls, or loading things into memory in different, you know, huge chunks or small chunks, or, you know, whatever optimizations you can think of. There's a whole world here to doing fast IO that, you know, you can explore, and feel free to share with the community. Anyways, folks, thanks for your time and attention. Hopefully you enjoyed this lesson, and I'll look forward to seeing you in the next one.